Hi, welcome to MooMooMath. Today we're going to look at dot products of vectors. So on the screen we actually have the operation. So if you have two vectors, we'll start with vector u. Okay, a vector is, as far as symbols, you're going to have a lowercase letter with a little vector symbol, and the vector symbol is kind of hard to see on there, but it looks like an arrow that only has one side on it. So we've got vector u, and it's defined as u1 and u2 for its position, and vector v defined by v1 and v2. Now, when we take the dot product, so we're going to see the symbol with a dot in the middle, we're going to take the first components and we're going to multiply those together, and then we're going to add to that the product of the second components. And then what we get is the result is actually a scalar multiple. We're going to get a constant as a solution. So there's going to be a number. There's not going to be a vector. Okay, so let's look at some of the properties of dot products. So we defined on the first screen what a dot product is and how to calculate that. So you've got your two vectors and you're multiplying the first component and adding the product of the second component. But as far as other properties with dot products, if you have vectors u, v, and w, so now we're looking at three vectors. Here are some of the properties that apply to dot products. U times v, or the dot product of u and v, is equal to the dot product of v dot product u. So this is commutative. We can change the order and we still get the same answer. And remember, the answer is a scalar. It's a number. Okay, the second property is when we take 0 times any vector, we get 0. So 0 times a vector is the answer 0, because remember, the answer is a scalar. It's a number. When we're adding two vectors, okay, we know how to add. We just add the components. So in other words, we end up taking the dot product of u time dot product, and then this will be another vector. So that's going to be the same as if we took the dot product of u and we added together the dot product of w, u and w. So we're going to get the same solution that way. Okay, the next property is v times v, so a vector times it's a dot product of another vector. That's the same as the magnitude squared. So remember these symbols, that means the magnitude or the length. So basically, when you take vector times the dot product of another vector, you're getting the magnitude squared. And then the last property is when you have a constant. So C is a constant, and you're multiplying it times a dot product. That is the same as if you take the constant times either vector. Now, notice we're not multiplying it times both. You can take the dot product first and then multiply by that constant scalar, or you can take the constant scalar times one or the other, but not both. And those are basic properties. Now let's start by just finding a dot product. So what do we mean by finding a dot product? We're just going to take the first component, take its product, and we're going to add the product of the second component. So we're going to take, 4 times 2. We're going to add to it 5 times 3. So we end up with 8 plus 15. So the dot product of 4, 5, the vector, and 2, 3, the vector, is just 23. And that answer is a constant. So let's look at a second one. So we're taking the vector 2, -1, and the dot product of 1, 2. So we're going to take 2 times 1, and we're going to add to it -1 times 2. Well, that gives us 2 plus -2, and that gives us a dot product of 0. Now, that dot product of 0 has a special meaning. So I'm going to draw this so you can see what this means. Okay, I'm going to take the first vector, 2, -1. So 2, -1, and draw that vector. And then 1, 2, and I'm going to draw that vector. Now, I hope you notice that these two are actually perpendicular to each other. So anytime you have a dot product of 0, it means that the vectors are perpendicular. Okay, that's a big theme here. So a dot product of 0 means that two vectors are perpendicular to each other. Now, let's do some operations. That screen that had all those operations, let's actually calculate some of those. So we're taking the dot product of u and v, and we're going to take that answer and we're going to multiply it times the vector w. Now, u dot product v will be a constant. Then we're going to take that constant and it becomes a scalar times w. So let's first start with u times v. So u is -1, 3, and I'm going to find the dot product with 2, -4. And that's going to be based on order of operations. We're going to find that first, then we're going to multiply it times w. Okay, so let's find the dot product. So that's -2 plus 3 times -4 is -12. So our dot product is -14. So that becomes a scalar. I'm now going to multiply it times the vector w. So I'm going to bring w down, 1, -2, and I can multiply -14 as a scalar. Whoops, I don't want to show my solution yet. Okay, my solution is -1, or -14, +28. And there is the product, the dot product of u times v all times w. That would be -14 and 28. So there's our first operation. You're going to have several of these to work on. Now let's take u times 2v. So in other words, this 2, we have got to apply a scalar multiple to v. So I've got to double v first and then multiply by u. So u is -1, 3. I'm going to multiply that times 2 times v, and that is 2, -4. So I'm going to apply this scalar first, and that vector becomes 4, -8. Very simple. You're just multiplying by a scalar. And now I'm going to take that times the vector u. So the dot product of u and 2v is going to be -4 plus -24, which is -28. So that ended up being a scalar, a constant value. Why? Because I'm multiplying a vector with a dot product. Okay? Now let's find the magnitude of u. Now to find the magnitude of u, I'm just going to take u times u. And then once I get that, that's going to give me u squared, right? So u times u is going to give me the magnitude based on that definition of u squared. So once I get to here, I'm just going to take the square root of that answer and I can get just the magnitude of u. So let's find this dot product. So -1 times -1 is 1 plus 3 times 3 is 9. So that means u squared is 10. Well, I want just the magnitude of u, so I'm going to take the square root of 10. And there is the answer. And that one won't simplify. So that is the magnitude of u. Okay, just so we'll double check, make sure everything looks good. Now, that's where we're going to stop on just the operations of dot products, how to find a dot product, and then how to apply some of those properties. Hope this video was helpful.